Next, we are going to see about session request protocol. We know that in OTG, two important protocols. First one is HNP, host negotiation protocol. The second one is session request protocol. So far we have seen that HNP, host negotiation protocol. Now we are going to see about session request protocol. Okay. And one more thing, session request protocol. In that session request, who will request the session? B device, right?
Okay,
In OTG concept, totally we have two kinds of device: A device and B device.
right.
Who will start this protocol? Session request protocol. B device,
B device.
because B device don't have the capability to drive the bus.
Okay,
It depends on A device to get the power.
okay,
So it will request the A device to give power.
okay,
So how it will going to give that request? What is the process? It's residing in this SRP. So
Okay.
these are all things we are going to see in this SRP.
So in this session request protocol, okay,
Okay.
like B device can give a request at any time, or when bus is idle, then only it can give this
When
request.
bus is idle, then only it
Then
will
only
give.
it
Yeah.
can give. Okay, okay, fine.
So the objective of SRP is to give B device a way to request and A device to turn on the VBus. When VBus is on, the session is in progress. VBus is on, session is in progress, and B device may get control of the bus if it is dual role.
So
Why
suppose
they mentioned dual role here means we in B device itself one more special category is there. What is that? B device with peripheral only mode.
okay,
We have discussed that thing. That's why they have mentioned here that dual role.
yeah, yeah. See, if your B device is self-powered,
Okay.
in that case also device need to take power from the bus.
No, actually B device in the sense that it will going to act as a default slave. Okay.
Okay,
In that case, it will not going to drive the bus. It has to get the power from A device.
okay. So means there must be some B device has to take some power from A device
Right.
at initial phases.
Right.
Okay.
Then note, even if the A device and B device exchange their roles due to HNP, the A device still supplies VBus. I think your doubt is clear now.
Right, right, right.
Next, we are going to see about how this session request protocol is happening. Okay. First B device, what it will do? It will pulses its pull-up resistor. That is called data line pulsing. There are two methods are there to do this SRP mechanism. First method is data line pulsing. Second method is VBus pulsing.
Okay.
So this is implementer's choice. Implementers can implement both the things, or he can implement only either one of these, data line pulsing or VBus pulsing. So these things will be generated by B device. Okay. VBus pulsing in the sense that B device will charge VBus to a particular voltage level, that is less than 2.0 volts. Okay. And then A device must, how the A device will respond for this one, this SRP request. A device will respond by can use a comparator or TTL input for deduction of VBus pulsing. Pulse in the sense that it will going to be high for a very short duration, right? So A device has to deduct this VBus pulse from B device. How it will deduct? By using this comparator logic. And since it did not start the session, it can quickly give the B device permission to assume bus mastership. Okay. First, we are going to see about the data line pulsing. Two methods are there in SRP mechanism. SRP will be done by either one of these two mechanisms. Sorry, two methods. First one is data line pulsing. Second is VBus pulsing. First, we are going to see about data line pulsing. Data line pulsing, in the sense that B device turns on its data line pull-up resistor. data line in the sense that D plus or D minus for a period within the range specified by TB data pulse. In specification they mentioned a particular time duration for this attribute name. Okay, so it has to make high either one of D plus or D minus line for a particular amount of time. The on-the-go B device is only allowed to initiate SRP at the full speed. This is one more important thing. Okay, and thus shall only pull up D plus.
Okay.
The duration of such data line pulse is sufficient to allow the A device to reject spurious voltage transients on the data lines. They fixed the duration in such a way that A device will not consider that pulse as a noisy one. And last, an A device that is designed to detect the data line pulsing of SRP shall generate an SRP indication if either D plus goes high or D minus goes high. Okay, either one of D plus or D minus goes high means it will consider it as a pulse, data line pulsing. The second method is V-bus pulsing. So data line pulsing means either one of D plus D minus lines will give a pulse like signal, right? What is data line pulsing means? B device drives that V-bus. We know that in OTG we have 5 pins, VCC, D plus, D minus, ground, and fifth one is ID.
ID, right.
We know that in general in USB system we have 4 lines. In OTG extra line is ID. So here V-bus means that VCC only. Okay. So B device will drive this V-bus. You may have the doubt. B device means it will not get the it will not don't have capability to generate a power. Right. But during this session request protocol mechanism, it will generate a small amount of power to drive this V-bus. After that it will not drive because it will get the power from host. Okay, and that's why they mentioned in this slide that it may drive up to 2.0 volts. Okay. Maximum I think 5 volt. Okay, in V-bus we can drive up to 5 volts, but V-bus pulsing means it can drive up to less than 2 volts. Very small amount of power to give a small indication to host. Okay, so this is called V-bus pulsing, and here they mentioned that the capacitance related stuff in second point. V-bus is driven for a period that is long enough for a capacitance on the V-bus that is smaller than the twice the value of some value they mentioned. Okay, so far we have seen the two methods to initiate this SRP, right? Now we are going to see about the pictorial representation of this SRP mechanism. First, this is the A device side, this is B device side. Okay, A device is in idle state. Okay, B device is also in idle state. Now it wants to start the session. For that it needs power. So what it will do, it will go to that SRP init state. There it will do that SRP